Hello everyone and welcome back to the AMS tutorial. Today we will learn that how our device behave when we shine light on it. So this is the interface of our software. We know that we should fix all the ambient condition, and then we need to load our previous device which we have uh, saved on the name of first layer, if you remember. So I need to click OK, then run. Yes, wait for a few seconds, and this is the JB curve, this is the energy band, these are the carrier generation and recombination. Today we will learn that how our device generate the uh, charges and what are the recombination over there. So let's say we copy this data and let's say analyze it. For example, paste over here. So we have three columns. The first column refer to the position of our device. The second refer to the recombination per unit volume, and the third column is referred to the generation of the photo excited charges. So let's say we want to see it on the graph. So we have two y-axis, so we need to plot double y over here. If we see, so this is a little bit different from this one. So on the y-axis, if we see, so this is actually the log of these recombination and generation. So we can make it like this. So for example, let's say on y-axis I want to fix some scales. Let's say this is 0, and for example this is 24, and let's say the gap is 5. So we apply it. Now similarly for this y-axis we need to fix some scales to make it look like that as in the simulation software. So let's do it like it's the 5 gap, and let's say that is in the log of the values. So we need to take the log. This is linear type, and this log it. Okay, apply. And similarly with this y-axis we will do that. So linear, take log, apply it. Okay, and no, it didn't take the gap, so take it like 5. Okay, and this is K5, apply. Now we can also fix the x-axis, which is actually start from 0 to, if we remember, so this actually the total position of our devices based on these layers. So it is approximately 0.52 microns, and I want to keep the gap 0.05. Now if we see in this simulation software, so the length of the or the thickness of our titania is around 0.02. So this is actually the position in the simulation, and this is for the perovskite, this is for the spiral. So we can deal that over here like this. First I need to make it a little bit bold so that we can see it. Okay, I think now it is easy to see. Okay, this is actually the black squares are for the recombination, and the blue one is for the generation. So if we analyze our device in this simulation, this actually, this portion is belong to the, for example, around about here. This is actually for the titania. Okay, I will make it like dash line so we can separate from the previous one. Okay, this one is okay. Okay, so this is a of our titania layer, and this one is actually around about here, I think so. This is the perovskite layer in the middle, and on the right side it refers to the spiral. So if we represent these lines, let's say I want to represent this in the bold, and for example this is ETL. Okay, this portion is actually the ETL, and this portion is actually the HTL over here. And this one is referred to the active layers. In this case it is methylammonium lead iodide. So, or the, we can say, active layer. Okay, so this is our device under illumination. Now for example, I want to study the behavior of this device, so we can see for example, if we look at the active layer or the perovskite layer, so the generation of charges is higher than the recombination. So in this case we can say that our device is a little bit better in comparison. For example, if the recombination increase, so that will mean that will analyze, or that will say that that the device has a large defects, we can say, in this layer, or the charges are trapped within the active layer. So we may have less or lower performance of the device, and we can play around the active layer to make it defect less, or we can say defect free. So that will show us that the recombination will decrease, and up to some level the generation will increase, and that is what we want for our best devices. And for example, if I want to play around the defects of the active layer, so we can do that by decreasing defects within the perovskite in the simulation, and it will tell us that the generation is increased and the recombination is reduced. So this is actually the analysis of our device under elimination with some specific defects within the uh, active layer. For example, if we see over here, let's say this is active layer, so here is the defects. So defects, in this case, the density of the defects is around 10 to the power 17. So it is quite realistic approach, because this is a very high value for the defects. If you want to decrease, so we have to make a very good layer of the perovskite. And thank you so much. See you next time.